So folks, Unit 2 is our heaviest vocab part of the term test and kind of easy things to get mixed up. So what I recommend for this part of the test is that you, one, know how to ID a conic in general form. So how to ID from general form. Which is this gross nonsense for how we have those equations written. What do the standard form equations look like? They've got fractions with them unless we're talking about a circle, but the general form equations are kind of the long drawn out ones, so we need to know what conic we're trying to get. You can find those instructions on page 8 of your Unit 2 notes. You'll also need to show you're completing the square work. Which is on page 9. And then study the vocab. Circles, page 3. Ellipses, page 4. Hyperbolas, page 6. And that's it. We didn't do anything with the parabolas first time around, other than identify them. We're not even going to do that on the final. So that's where you will find all that vocab. And folks, we're going to be hitting all that here, but if you feel like you need more review or you're not sure about the individual parts, that's going to be where you will check. So folks, we're going to go ahead and start by looking at these two equations and see if we can determine the type of conic section that they are. So this is how to identify a conic section from general form. So I'm going to go ahead and go to that part of the notes where we can see those steps. Page 8. And there they are. How to ID a conic in general form. So first, identify which variable is getting squared. So who's getting squared in this equation? X and Y are both getting squared. So can't be a parabola, and I already told you we're not doing any parabolas on this test. X squared and Y squared have to be on the same side before you start comparing the other features. For a circle, the coefficients of those square terms will be the same. Is this a circle? No. For ellipses, the coefficients need to be different and have the same signs. This is an ellipse. For hyperbolas, we're going to have different coefficients as well with different signs. And why that those kind of steps are important is because they really mimic the signs between the fractions in the standard form. So here's standard form for an ellipse. We see the plus sign, which mimics the same signs in general form. Here we see the hyperbola, which has the minus signs, which mimics the different signs in general form. And then a circle, which is up here, doesn't have any fractions and it doesn't have any coefficients. So that's when those coefficients are the same. You will know you are dealing with a circle. So folks, we have determined that this is an ellipse. And again, an ellipse equation has a plus sign in between the fractions. It is equal to 1. That will be important as we start completing the square. And remember, it kind of mimics the different denominators that we will have with those coefficients. See if you can determine what the next conic section is from the general form. We got x squared and y squared, different coefficients and different signs. What is it? hyperbola. So minus in the standard form equation and hyperbola equations are also equal to 1. The hardest part about this unit is how annoyingly similar these two conic sections are. There's a lot of similarities, but those differences are what can make these problems tougher. So we're going to start with something that they have in common, which is how we turn the general form equations into standard form by completing the square. So we're going to start by grouping our x stuff together and simultaneously take out the coefficient of the x squared term from both of those. So we're going to put these together and we're going to take out that 25 like a GCF from both of them. That will leave me with x squared, negative 150 divided by 25 is negative 6x. So I took the 25 out of both my x terms, and then I put in the blank so I can complete the square. Because our goal is we want to trick this into being factorable as a perfect square so that I can make it look like x minus h squared and y minus k squared. So moving on to our y stuff. Grouping it together, and we're going to take out the coefficient of the y squared term from both of the y terms. That will leave me with y squared, then what? Plus 2y. Put in a blank. If we had any constants on the left side, we'd shift them over to the right side to kind of get them out of the way so we can complete the square. So the negative 129 is just going to chill on the other side. So that's our setup for completing the square. Do we remember doing these? So the trick with actually completing the square is it is out of order factoring. So I'm still looking for a product of negative 6, sorry, a sum of negative 6 and a product of something, and we do it in a special out of order way. So our guiding process here is what are two numbers that are the same that give me a sum of negative 6? Negative 3 and negative 3. What product number or C value will those give me? 9. So 9 goes in the blank. All right, now this is the part that was hard when we did this back in Unit 2. We're adding 9 in that blank, but what are we really adding to the left side of that equation? Whatever 25 times 9 is. And I'll save us a little time and tell you that it is 225. Remembering to keep the equation in balance is a common error, along with multiplying by the coefficient you have out in front of the parentheses. See if you can complete the square with the y stuff. Two numbers that are the same that give us a sum of 2, 1 and 1. What product number do those give us? Careful. 1. So it's really easy to say 2. So again, make sure you get enough sleep the night before the final, Monday night. So 1 is what's going in the blank, but what are we really adding to this side? 4 times 1 or positive 4. So wonderful. At this point, we are now ready to factor these perfect square trinomials that we have made. So 25, x minus 3 times x minus 3, or x minus 3 squared. So that gives us our sum of 6, product of 9. And then plus 4 times y plus 1 times y plus 1, or y plus 1 squared. And then the constant we get on the other side is 100. This is what we have. This is what we want. Any ideas how we're going to make it look like this? Divide by 100. It has to be equal to 1. And what's nice is this step provides a decent check for us because these coefficients in front of your parentheses must cancel. If they don't cancel, it means you goofed somewhere. Either your blank number is wrong, or maybe you didn't factor out this from both of the terms, or maybe you forgot to straight up add the blanks in on the other side, or you didn't multiply by that coefficient out in front. So things not canceling, that's a red flag. So luckily for us, things are canceling. 25 cancels out with the 100. 4 cancels out with the 100. And what's 100 divided by 100? Not 0. 1. Don't forget to type the 0, or not the 0, don't forget to type the 1 on my math lab. So we are writing the standard form equation. That's lunch. See you after lunch.